Hello and welcome to 5-10. We're going to go back to our roots here a little bit and solve some fraction equations using multiplication and division. So that would be our equations where we were like 5x equals, sorry that's an equal sign, 25. Then I would divide by 5 because this is showing multiplication. So I do my inverse operation of multiplication, which is division. So then these would cross out, and I'd be left with x equals top divided by the bottom, or 25 divided by 5, which the answer would be 5. And this is how I would show my answer. So we're just going to do that, except for now we get to work with some fractions. So we'll talk a little bit about that. I also wanted to touch down here, our goal is to solve equations by multiplying and dividing fractions. And I will use the inverse, or the opposite, operation to solve multiplication and division equations. Let's get started. Okay, so here I have my number, a fraction, next to my variable, which means I'm multiplying 2/3 times k. And it's going to equal 14. So I need to divide both sides by 2/3. Divide by 2/3 to get my answer. So 2/3 divided by 2/3 cross out to make 1. So I'm left with k equals. Then I'm going to do my work off to the side. 14 over 1. Then I find my reciprocal, so I'd put my 3 as my numerator, my 2 as my denominator, change it to multiplying. I could divide by 2, and my numerator would be 7 times 3, or 21. I don't know why my first part of my 2 doesn't want to write. 21. My denominator is going to be 1, so really all I need to have is k equals 21. Now, if I want to go back and check my work, I could do 2/3 times 21 over 1, and it should get me a 14. So if I divide this by 3, divide this by 3, I would really get 2 times 7, so I would get 14 equals 14, and it does check out. So if it does tell you to check your work, you better check your work. And that's the way you can know 100% that you are correct. Especially with working with fractions. It's not always obvious if you got the question right or wrong, at least for myself. So it's always good to double check that. All right, let's do another one. So this one I'm going to divide by 2. 2x equals 1/3. So 2x, I'd have to divide by 2 to get rid of it. Then I can divide by 2 right here. So if I found the reciprocal of my divisor, I would do 1/2, and really I'm multiplying by 1/2. What am I multiplying by 1/2? I'd be multiplying 1/3. So that would equal 1/6. So x equals 1/6. And if I wanted to check that out, I would do 2 times 1/6, and I should get a 1/3. So I would simplify, divide by 2, divide by 2. Yep, I'd get 1/3 equals 1/3. All right, let's do another one. All right, now one like this is a little tricky. It looks like the 5x is the numerator and the 6 is the denominator. So then you'd be like, well, what am I going to do? This is the same as if I wrote it 5/6 x equals 4. These are both meaning the same things. So if I see something like this, I know I'm going to divide both sides by 5/6. Okay, so really I can separate the x and move it on the outside, or I can put it as my numerator. My x would never go to my denominator though. So if I divided this out, I would find the reciprocal of my divisor. So I would do 6/5. And we can cross out these, so I'm just left with x equals 6/5 times our dividend, 4/1. No, I can't do any simplifying. So 4 times 6 is 24. Over 1 times 5 is 5. Okay. Now I need to do top divided by the bottom. 5 goes into 24 4 times. And I'm left with 4, so my answer would be 4 4/5. So then I would just write over here x equals 4 4/5. Okay, let's do my quotient. Oh, I better use proper terms here. The quotient would be 4 4/5, so x equals 4 4/5. All right, let's try a word problem now. Dexter makes dog biscuits for the animal shelter. He makes 1/3 of a recipe and uses 15 cups of powdered milk. How many cups of powdered milk are in the recipe? All right, so when I'm thinking about this one, I'm thinking, okay, I have X amount of cups of milk of powdered milk in the full recipe. And he is going to make 1/3 of that, so I multiply by 1/3, and then that's going to give me the 15 cups that are left over. So the amount of cups in the original recipe, I'm going to take 1/3 of that, and now I have 15. If I put this in terms not using fractions, I could say I'm going to make half of the recipe, and now I'm using 12 cups. How many cups were in the original recipe? So in that case, I would do x times. So I have my original recipe. I'm going to multiply that by 1/2. And now I'm using 12 cups. How many cups did I use in total? Well, or how many cups were in the original recipe? I would just multiply that by 2, or the reciprocal of 1/2. So if we started with 24 cups, I multiplied it by 1/2, I would get 12. Same thing, it's just we're using numbers we're not quite familiar with. So that's why I always like to put more familiar numbers in the problem to hopefully help my understanding. So I'm going to divide both sides by 1/3. Divide by 1/3. So these will cross out. I'm left with x equals. So really I'm doing 15 times 3/1, or just 3. So 15 times 3 is 45. 45 cups were in the original recipe. So if that makes sense, the original recipe called for 45 cups. I wanted to make 1/3 of the recipe, so I used 15 cups. Yep, that makes sense. I can always double check my work, but if we have the wrong equation, then we're going to get the wrong answer, and it would still work if we checked it. So we want to use our common sense and say, does that make sense, if that was the answer? In this case, it does. All right, that's all that I have for you for today. Thank you for watching, and we'll see you tomorrow to get our assignment done.